Okay, hello. Let's talk about lipids. So, before we get into it, I just kind of want to remind you guys, thinking back to the larger picture as to why we are talking about these particular macromolecules. And we'll talk about, the purpose of lipids in particular. But remember, when we're talking about water and when we're talking about these macromolecules, the reason why we are going in depth with these is because all of these molecules are important or necessary for life. So in particular, lipids are carbon compounds. So remember we talked about carbon and the importance of carbon. So they're carbon compounds that are insoluble in water. So remember, insoluble means that they cannot be dissolved in water. And when they're insoluble in water, that's because they're nonpolar. So an example of a lipid would be a triglyceride. Tri meaning three. So there are three fatty acids, and then glyceride stands for like the glycerol. So triglycerides form by condensation reactions. And in particular, there are three condensation reactions. And you can see in this picture right here that these bonds form here, here, and here. And these bonds are called ester bonds. Okay? And so you're going to end up having three waters as a byproduct of these condensation reactions. So remember, condensation reactions are an example of anabolism. Oops, I don't know why this isn't writing. Anabolism. Okay, so we're building molecules. Okay, and then hopefully you guys remember from last week when you had to build that concept map. You should have remembered hopefully the function of lipids versus kind of the function of carbohydrates. So carbohydrates are important mainly because they are short-term energy. So those of you who play sports have probably heard of like carbo loading. So it is short-term energy. You eat all those carbs to then be able to burn them off really quickly when you're running a long race or, playing a game when you're out on the field or on the court or whatever. Lipids, on the other hand, are long-term energy, okay? And there are some differences between carbohydrates and lipids that kind of make them different, make them better, lipids better at long-term energy as opposed to carbohydrates, which are better at short-term energy. So lipids actually are able to release twice the amount of energy as opposed to carbs, which release less energy. And lipids can actually be used as heat insulators. Lipids also occupy less space, and that's important because as humans, but also a lot of organisms carry fat we carry it around with us as adipose tissue. So 2 reasons for that. We carry fat around with us because it's long-term energy, it can provide energy for us. But then there are also, penguins and other animals that live, on either poles or up north or more down south that use, lipids as heat insulators, as a way to keep warm. And if we just kind of look back at carbohydrates, they're short-term energy, and they're soluble, so they can be dissolved in water, which makes them more easily transported by blood. Okay. So remember, we talked about one of the parts of lipids are fatty acids. So one of the next things that we do is we want to go in depth with fatty acids. So you guys have to be able to draw a saturated fatty acid. Their IB may ask, draw, and one of the questions may simply be draw a saturated fatty acid. So a saturated fatty acid, and why we call it saturated, is it has as many hydrogens as it can possibly have. Okay, so when we draw a saturated fatty acid, we first start with what's in red. We start with the carboxyl group right here at the end. Okay, and remember, I think of it as CHOO. So our COOH group, our carboxyl group. And this, in terms of saturated fatty acids, the carboxyl, particularly the double bond between the carbon and the oxygen, there are no other double bonds in a saturated fatty acid. Okay, so on one side, we start with the CHOO, the carboxyl group. And then we usually have anywhere between 14 and 20 carbons in our fatty acids. Sometimes they can be more or less, but generally it's going to be between 14 and 20 total carbons. And then the only thing else that you have to remember is the last three carbons, the last carbon on the end is going to be bonded to 3 hydrogens. So it kind of looks like a scary molecule. It's just a long molecule. It is a fairly simple molecule, but that is a saturated fatty acid, okay? Because again, saturated, it has as many as many hydrogens as it can possibly have. So it is saturated with hydrogens, okay? And then we have unsaturated fatty acids. So unsaturated fatty acids have one or more double bonds between carbons, and they can only be, we would only categorize it as an unsaturated fatty acid if the double bond was between the carbons. So like you can kind of see, it still has the CHOO all the way on the left, the COH and the C double bonded to the oxygen. And it's still going to have 14 to 20 carbons, but then it'll have at least one double bond between the carbons, okay? And if there's only one double bond, we call it mono. We call it a mono unsaturated fatty acid. If there were 2 or more, I can write this right here. So if there were 2 or more double bonds, it would be a poly unsaturated fatty acid, okay? I'm gonna run out of room, but you get what I mean. So it's called a polyunsaturated fat if there's 2 or more. If there's only one, it's monounsaturated, okay? And then, again, we have lots of different unsaturated fatty acids. So because there's a double bond, you can put the hydrogens, technically the hydrogens can go on either side of the molecule. If the hydrogens are on the same side, like on this picture right here, this guy, so this one right here, you can see that the hydrogens are on the same side. And so cis means same. So the hydrogens are on the same side, okay? And cis unsaturated fatty acids can occur and can be synthesized like organically. But then we also have trans unsaturated fatty acids where, as you can see in the purple, the hydrogens are on opposite sides. So trans means across, so they're across from each other. And so with cis unsaturated fatty acids, you can see in this picture, it kind of creates like a bend in the molecule, okay? But then with trans, the bonds, there's no kind of bend, so it kind of is like it's a straight molecule. And trans unsaturated fatty acids are actually usually only artificially made. And they are usually solids at room temperature. So think about something like margarine would be an example of a trans unsaturated fatty acid. Okay? And so this is a pretty short, not too much information, but the last little bit that we're going to talk about are, fats and lipids and how they relate to health. So we just talked about, or I just mentioned that trans fats are artificially made, okay? And so there have been a lot of studies that have basically not proven, of course, it's very hard to prove something in science, but there's been enough studies where it's very likely that having a diet with lots of trans fats can cause coronary heart disease, or essentially heart disease. And if you have heart disease, you can potentially, have heart attacks. You're more likely to have heart attacks. You have, a buildup of a buildup in your arteries, so that can cause heart attacks. So trans fats are generally considered to be like, quote unquote, the worst fats, or the most unhealthy fats. Saturated fats, there have been a lot of studies that say that there's a positive correlation between saturated fats and coronary heart disease. But I mean, we've talked about how, or hopefully you've talked about how correlation does not equal causation. So it's likely that, I would say saturated fats may cause coronary heart disease, but there could be other factors at play. So a diet with lots of saturated fats also may be low in like fiber. And fiber, like low fiber diets, can also cause coronary heart disease. So there may be other kind of risk factors at play. And then the last thing is that there's been lots of studies that have supported the idea that populations that eat diets that have lots of cis monosaturated fatty acids actually have lower rates of coronary heart disease. So cis monounsaturated fatty acids, examples would be like oils. So they talk about like in the textbook, they talk about like the Mediterranean, people in the Mediterranean who, have lots of like oils, and like think about like, I always think about very like Greek diets that have lots of oil and vinegar, things like that. They generally have lower rates of coronary heart disease. But again, that may be because of genetic factors and other dietary factors at play. There's not enough data out there to really prove or, support without a doubt that cis monounsaturated fatty acids really do, help improve or lower the risk of coronary heart disease. okay? And then the last thing that we'll talk about is BMI. So BMI, oh, hold on, I gotta pause. I'll be right back. All right, I'm back. Sorry. So, as I was saying, BMI. I'm going to write this. BMI. So, BMI stands for body mass index. Okay? So, I just like to. There we go. So, BMI. So, the way that you calculate body mass index is basically by taking your mass. In this case, remember, we are in science, so we're going to use the metric system. So what you do is you take your mass in kilograms and you divide it by your height in meters. Okay, and that will give you essentially somewhere on this graph is where your BMI will lie. And then based on what your BMI value is, it will give you a classification as to whether you are considered underweight, normal weight, overweight, or obese. So IB loves this graph, this BMI index. So it's the nice thing is that it's super easy to read. So I don't know why I'm spending so much time picking a color. Let's just go with this one. Okay, so if I'm an individual, or if there's an individual who is 90 kilograms, so you can find, again, we're looking at weight. So we've got 90 kilograms. So I'm just gonna draw a little line. And then this individual is 185 centimeters. So here I am, 185, and I could draw another line. And oh my God, this is where, right here, is where my two data points intersect. And essentially, this is the BMI of this individual. And so it's obviously somewhere between 25 and 30. So we can see 25, and then we can come up here and we say, 25 to 29, that individual is considered overweight. So this individual will be classified as overweight according to the BMI. A couple things about the BMI that I think are important to at least discuss or talk about. And one of the things that I would like us to do, and we'll make this an activity, is we will kind of look at some of the history behind the BMI, because basically where this came from has a lot of, it's not a very accurate measurement of health, because health is always considered to be something that is more than just your height and your weight. There are a lot of things that go into health and your general wellness. There's also a lot of historical context to the BMI and how this number and this calculation kind of came to be. And generally, a lot of the data that was used to come up with this graph right here came from a specific group of individuals in these studies who were primarily white young men. So we'll go into more depth with this. I kind of have a plan to give you guys information and research from kind of both sides of the argument, and then you can kind of reflect and, make your own opinion about it as to whether, you think the BMI is a good measure of health or whether it is not. But that's just something to think about. And like I said, we'll do more when I give you the assignment. But that's pretty much all you guys need to know about lipids. So, bye-bye.